All right, so when solving radical equations like this, radical just means some sort of a root. In this case, they're square roots. When solving radical equations like this, the first thing we want to do is get the radical part by itself. So in the case of that first one then, we need to get rid of the minus 4. And how do we get rid of the minus 4? Add 4 to both sides, right? So start by adding 4 to both sides. That then gives us the square root of x equals 9. Now we can actually work on getting rid of the square root. What undoes a square root? What can we do to a square root that makes it go away, in other words? Square. Yep, because a square undoes a square root. And so we're now going to square both sides. So I'm squaring the square root on the left. That cancels out the square root and leaves us with whatever was inside of the square root exactly as it was. So that in this case, that's an x. And on the right side, we do the 9 squared, which gives us 81. Notice in this particular problem, that left us with x equals. X is by itself on the left side, so that means we're done. That's our answer, x equals 81. For the second one now, we again need to start by getting the square root by itself. So what are we going to do first? So 3, right? So we subtract 3 from both sides. That then gives us the square root of x plus 5 equals 4. I now need, well, what do we need to do? Can I move the 5 out of there? No. Notice the 5, it's trapped inside of the square root. And as long as that square root is over it, I can't pull it out. So what we have to do then is we have to get rid of the square root. So I go ahead and square both sides at this point. So notice the pattern. We get the square root by itself, then we square both sides. Having done that, we then finish solving it out. So in this case, that means we got x plus 5 equals 16. I still need to get what x equals, so I'm going to subtract 5 from both sides. Gives us x equals 11, final answer. All right, we're going to be doing a number of different practice problems like these today. Some of them are just going to be small variations on the same thing. Others are going to be ways that we can illustrate some little details and some subtleties and other things that square root equations might bring in for us to deal with. And so we'll be looking at some special cases along the way as well. All right, so let's take on the next set of questions. Go ahead and on your paper write down each one and go ahead and solve it out. Solve each one for x. And then we'll go through it together to see what happens with these. All right, now solve them. And the first one, remember I have to get the square root by itself first, so that means moving the 1. So I subtract 1 from both sides. I end up with the square root of 3x equals 6. Now I need to get rid of the square root because it's by itself on the left side. That means we square both sides of the equation, which leaves me on the left side with 3x. Notice it's still 3x because the square cancels out the square root. It leaves whatever was inside of it exactly as it was, so it leaves it 3x. So if 3x equals 36, then that's 3 times x. So to undo it, I'm going to divide by 3. And 36 divided by 3 is 12. So there's your final answer. Now the second one here, this one's got a bit of one of those wrinkles in it that I was mentioning. If I go through and solve this one out, I square both sides and then I subtract 2 and I end up with x equals 79, which looks great except that there's a little bit of a problem. This solution actually doesn't work. Let me prove you that. If I plug the 79 back into the original equation, 79 plus 2 is 81. The square root of 81 is 9. But this is supposed to equal negative 9, not 9. Do you see why the problem occurred? Can a square root ever give us a negative? No. Square roots always equal positive numbers, or 0 technically. But it can never equal a negative. And so anytime you see a situation like this, we can actually go to saying it's no solution from the start. Now a little bit of detail and clarification along here. We know that it's no solution because we have the absolute value. Why did I say absolute value? We have the square root by itself on the left side, and we have the negative on the right side. If you have the square root by itself, equal to a negative, it's no solution. But notice, in order to say that, you have to have the square root by itself first. Once you see that you have the square root equal to a negative, you don't need to put in all of this stuff. All you need to do is once it equals a negative, you can go straight to saying, hey, it can't equal a negative, therefore no solution. And so this is the first of a couple unique rules that we have to remember when solving square root equations, that it can never equal a negative. And if it does, there's no solution. Right, next up. Please solve these two problems on your own paper. All right, so when solving this first one out, we start by needing to get the square root by itself first. That means getting rid of the 3. Since it's 3 times the square root, I undo that by dividing both sides by 3. So I now have the square root of x minus 1 equals 5. Now I can get rid of the square root. So we square both sides. We got x minus 1 equals 25. Now it's straightforward, I hope, to get the x. Add 1 to both sides, x equals 26. The second one is the one that tends to cause people a little bit of grief at times. Now, first up, I suggest getting rid of any addition or subtraction. So I would start by adding 1 to both sides. Having done that, we now need to get rid of the 1/2. Now, there's a couple different ways that people approach getting rid of the 1/2, but because I want to be very strict about illustrating why it is what it is, I'm going to talk about it in terms of, since it's 1/2 times the square root, I am going to undo it by dividing by 1/2. Now, after we do this, I'll mention the other way that you could think of it. So if I divide both sides by 1/2, on the left side that gets rid of the 1/2, but then on the right side I have to do 4 divided by 1/2, which hopefully is straightforward and easy, but generally isn't because we don't divide fractions all that often, so we sometimes forget. So I'm going to actually take some time and go into that in depth. If I'm going to do 4 divided by 1/2, I first want to make them both into fractions, so I make that into a 4 over 1 divided by 1/2. Now, in order to divide a fraction, I flip the second fraction and change it to multiplication. So it becomes 4 over 1 times 2 over 1. Notice only the second fraction flips. Technically, we are multiplying by the reciprocal, if you like the nice fancy math language. All right, so now I'm going to do 4 over 1 times 2 over 1. When multiplying fractions, you multiply straight across the top and straight across the bottom. So on the top, 4 times 2 is 8, and on the bottom, 1 times 1 is 1. So 8 over 1, well, that just equals 8. So we did 4 divided by 1/2 and we got 8. So dividing by 1/2 is the same as multiplying by 2. Because notice, dividing by 1/2 became multiplying by 2. So I wrote divide by 1/2. You could also have written multiply both sides by 2. It would give you the exact same value. Either way, it equals 8. So now that the square root is by itself, we square both sides. And so we have x plus 8 equals 64. In order to get x by itself, we subtract the 8 from both sides. You got x equals 56. So now we're going to take on these two problems. Both of these are going to bring something slightly new to our experience of what we've been doing. So write down the first problem. And yes, notice that is a cube root this time, as shown by the 3 that's in the crook of the radical there. So the question is, how do we get rid of a cube root? What are we going to do to both sides? Well, when it was a square root, what did we do to both sides? We squared it, right? So what do you suppose we're going to do to get rid of a cube root? We cube it. And so our first step, because we have the cube root by itself already, is that we are going to cube both sides. And yes, this will work no matter what kind of root it is. If it was a 4th root, we'd raise both sides to the power of 4. If it was the 7th root, we'd raise both sides to the power of 7. When we do that, we get 1 minus x equals 8. Now go ahead and finish solving it out from there. All right, so with that from there, we want to get rid of the 1 out of there. Notice it's a positive 1. So if I want to get rid of the 1, I need to subtract the 1 from both sides. But notice then that leaves me with a negative x equals 7. Okay, well, I still need to get x by itself. So how do I get rid of the negative? Well, negative x is just the same as negative 1 times x. So if I want to get x by itself, I can divide both sides by negative 1. And so 7 divided by negative 1 gives me a negative 7, so x equals negative 7 here. This one can be a little tricky. So good to be focusing on some of those details. All right, second one. Make sure you've written it down on your paper. If you haven't, do so. And then when we start the second one, we actually start it the same way that we start any of the other square root problems we've had. We start by getting the square root part by itself. In this case, that means getting rid of that minus x. So the opposite of subtracting x is adding x. So I add x to both sides. Now I have the square root by itself. Once I have the square root by itself before, I squared both sides. This is no different. I'm going to square both sides of that equation now. When we do so, we now have x plus 6 equals x squared, and then things get interesting. Because notice we have an equation here with an x and an x squared in it. If I'm going to solve that from there, I got to go back to my quadratics work. With solving quadratics, we could solve them by factoring or by using quadratic formula, but both of those methods required that the quadratic be set equal to 0. That means I'm going to have to move everything to one side of this equation so that it will be equal to 0. The question is, which side do I want to move everything to? Because, well, technically, either way works. One's going to be a lot easier. Because your life gets a lot easier when factoring if it's just a plain old x squared. That is, it's positive. So I don't want to move the x squared to the other side because that would make it negative. Instead, I'm going to move the 6 and the x both to the other side. So that means I will subtract x from both sides, and I will subtract 6 from both sides. Now I have 0 equals. That was my goal, was to get 0 equals. Because now I have a quadratic set equal to 0. I can solve it by either factoring or quadratic formula. Remember, only resort to quadratic formula if it's not factorable. Otherwise, you're going to do a heck of a lot more work than you have to. So the question is this one factorable? Are there two numbers that add to negative 1 and multiply to negative 6? Yeah, there are. We should get that those two numbers are negative 3 and 2. So we factor it as 0 equals x minus 3 times x plus 2. And we did all of that just so we could say what x equals. It's whatever makes them equal 0 each. So what minus 3 equals 0? 3, right? And what plus 2 equals 0? Negative 2. And so this one actually gave us two solutions. It's actually kind of along the lines of that's the good news right now. Because just like an infomercial, wait, there's more. Notice what we have here. This problem had an x on both the inside of the square root and an x on the outside of the square root. Whenever that happens, we have to check our solutions that result. Because sometimes both of those solutions are valid solutions. But sometimes only one of them is a valid solution, the other one isn't, and it's even possible for both of them to not work. So we got to check this. We check our solutions by taking each of the solutions and plugging them back into the original equation. So I'm going to start by checking the 3 here. And yes, you'll have to write this out anytime you have the x on both the inside and outside of the radical. So I plug in 3 for all the x's. Now when I'm checking this answer, I'm not solving. I am just figuring out what it equals. And so I just do the 3 plus 6 is 9. I don't want to move like the 3 over. I don't want to square both sides, because that could be the very thing that's giving me a potential false positive. You just figure out what it equals, just simplify it. So then the square root of 9, that's 3. And then 3 minus 3, that's 0. So we end up with the statement 0 equals 0. That is a true statement, therefore 3 is a solution. Now we check the negative 2. Again, I plug it in for all of the x's in the original equation. Always the original equation. Never one of the steps along the way. Otherwise, again, we might be plugging it in to the very thing that caused the false positive. And then simplify this result. So I do the negative 2 plus 6 inside the radical. That gives me 4. So then I do the square root of 4. Square root of 4 is 2. 2 plus 2 is 4, not 0. This gave us a statement that is not true. Therefore, that is not a solution. And so negative 2 is not a solution. Only 3 is the solution. So x equals 3 here. And that's it. Now, again, going back, because I want to make sure to save you some grief here. Do you have to check every solution every single time you solve a radical? No. It is only because the x was both inside and outside of the radical that we needed to do that. That's the only situation where you got to worry about doing it. Now, you can do it the rest of the time if you want, but you don't have to. All right, now, in this problem, we got a solution that looked like a solution, but it wasn't really. Well, these have their own special little name that we have to know. That solution was extra. And so we call it an extraneous solution. Notice the root for extraneous is just extra. That's the way to remember what it means. It just means it's an extra solution. It looks like it is, but when you check it, it isn't. This needs to go into your notes.